So A was okay. There we go. All right. Somebody did something. That's good. All right. So for part A, using the ratio test, we're just going to set this up, noting that for all values of x, this does not have positive terms, so we'll need to use an absolute value. So for part A, we should have set up a limit as n approaches infinity of the absolute value of -3 to the n plus 1 minus 1, which is just the n, x to the n plus 1 over n plus 1, and then we'll multiply by the reciprocal, so n over -3 to the n minus 1, x to the n. Everybody good with that? Okay. And then we would simplify -3 to the n over -3 to the n minus 1 should become what? Just a -3. Yeah, we can get rid of, we'll get rid of the negative balance. I guess we get rid of it. Anyway, -3 x to the n plus 1 over x to the n should just be an x in the numerator, and then we have an n in the numerator, and we have an n plus 1 in the denominator. Everybody good with that? Yeah? Okay. So then from there, we can rewrite this just as this limit should equal 3 times the absolute value of x, or the absolute value of 3x. Either way you want to write it, it's fine. And since it's the ratio test, we need to set that less than 1, which tells us that the absolute value of x is less than 1/3. So that tells us that r is 1/3. Everybody good there with part A? All right, that was worth 3 points. So you got 1 point for correctly setting up the ratio. You got 1 point for finding the limit. And you got 1 point for finding r. Any questions on part A? Everybody's good with part A? All right, part B, what was part B asking? Finding the first 4 non-zero terms for the Maclaurin series for f prime. So we can just, we can just differentiate the terms of f, but they only give us 3 of them, so we'd have to write out a 4th one. Or we can differentiate that series. We're probably going to want, we don't, it doesn't say we need the general term, but we can just find the general term and then plug in the values of n equal, plug in our n values. So, let's see, I have it written here. So we got negative, we started with x minus 3 halves x squared plus 3x cubed for n equals 1, 2, and 3. So what would it be at n equals 4? At n equals 4, we should have minus, what is it, 3/4 x to the 4th? I can hardly read what I've got on this. Is that the right? Yeah, minus 3/4 x to the 4th. That's the original series. So if we were to take our derivatives of that, this is f. So f prime ought to be 1 minus 3x plus 9x squared.
Shouldn't that be -3 to the n minus 1?
Oh, it's n minus 1, yeah. -3 to the
3.
Right?
Yeah.
So then that becomes minus 27 x to the 3rd. I just couldn't, I can hardly read. I've got the problem up on my phone, so I don't have to keep going back and forth. So it's very small on my phone. All right. There are your first 4 non-zero terms. That's all it asks for that one? No, express it as a rational function. So what is our general term was, what was it, -3 to the n minus 1 x to the n over n? Okay. So our general term should look like what? Or we don't even really need our general term because we can just look and see what what's happening here? This series is a geometric series. This is geometric, right? With a common ratio of -3. Each one's being multiplied by -3. And they're also all being multiplied by x. Do y'all agree with that? Yep. So we should be able to rewrite this then as 1/1 minus -3x. Or 1/1 plus 3x. And that was worth 3 points, 2 points for writing out those non-zero terms, and 1 point for getting this value. Everybody good with that? Cool.
Wait, so when they asked for expressing the derivative of f as a rational function, even though they just asked you to write out the first 4 terms of f, they don't want you writing the first 4 terms of f as a rational function, just the entire thing.
Yeah, they just want a representation of what function does the entire series represent.
Oh, oops.
Yeah.
Okay.
Yeah. Everybody good there now? Yeah. All right. So part C says write the first 4 non-zero terms for the Maclaurin series for e to the x. That should be easy. What should that be? Well, we just want the first 4 non-zero terms, which should be. Everybody agree with that? There's your first 4 non-zero terms for e to the x. They gave you 1 point for that. So just so long as you have that one memorized, you got that point. Right, easy. And then the second part of it is asking you to write out a series for what? E to the x times f, or yeah, e to the x times f, not f prime, right? Yeah, just e to the x times f. So and it says the first 3, no, first third degree Taylor polynomial for it. So e to the x times f of x, well, that's just a multiplication of 2 different series that we know. So this ought to just be 1 plus x squared over 2 plus x cubed over 6, and so on if we need them, times the series that we had for f of x, which was x minus 3 halves x squared plus 3x cubed, and so on. We don't need any more terms, though, because we can see that we want a third degree Taylor polynomial. So when we distribute all this through, 3x cubed times the 1 is going to give you us a power of 3. If we went any further to a 4th power, we're going to be always above third degree. Same with this one, we have a third degree here times the x, that's already above, so we're good enough there. We don't need any more terms to multiply out. So 1 times the x is going to be x. The 1 times the minus 3 halves x squared is going to be a minus 3 halves x squared. The 1 times the 3x cubed is going to be a 3x cubed. The x times the x is going to give you a plus x squared. The x times the minus 3 halves is going to be a minus 3 halves x cubed. The x times the 3x cubed I can ignore and not worry about because we want the third degree Taylor polynomial, and that's going to give us a 4th degree. And then x squared over 2 times the x is going to give us x cubed over 2, and then I don't need to worry about the x squared times the x squared because that goes beyond third degree again. Everybody good there? And so we just combine our like terms. What do we have? We have x minus 3 halves plus 1 should be minus 1 half x squared. 3 minus the 3 halves plus the 1 half, right, ought to be plus 2 x cubed. X minus 1 half x squared plus 2x cubed. And they gave you 2 points for that polynomial. Any questions on that? I don't know. If you got a different answer, then yes, you did it wrong. you're saying you took the generic terms of each of them and multiplied them together. What did that, let's see, what did that give you when you multiplied them together? Should have gave you, yeah, what? X? But what was your generic term that you came up with when you did it? -3. Where'd you get x to the 2n minus 1? Okay. Okay. And then what was in your denominator? N and n factorial. Just n factorial?
Yeah, it's n minus 1 factorial.
Oh, right. Yeah, the n minus 1. Is that what you did also, Jenna? You looked like you were nodding, or no? Oh, okay. Let me think about that, Noah. Let's see. -3 n minus 1 x to the 2n. Both of those started at n equals 1. Yeah, that would definitely leave out that squared term, huh? I don't know. Theoretically, no, it should not work. That should not work because you have to, if you're going to multiply two series together, you're going to have to multiply them term by term. You can multiply a constant into one, or like even a variable into one, but you cannot multiply the two series general terms together. You're going to have to write out the different terms and multiply them term by term. Now, any other questions on that one? Everybody feel okay about that process? Everybody do okay with that? Yeah, 3 points each for. All right, let's do another one. Yeah, so let's take a look at this next one. I think today we'll just focus on series ones. Tomorrow we will focus on area volume ones. And then Friday we'll have a quiz on area and volume and series. One of each probably. So I will give you guys about 15 minutes here again on this one. Sound good to everybody? All right, ready, go. All right, so for part A, we want to write out the first four non-zero terms and the general term for this series that they're talking about for f at x equals 1. So the first thing we want to note is that this is going to be about x equals 1, which means that as we write out these terms, we need to have x minus 1 to the n powers and then not x to the n's, around x equals 1. But that's not going to matter for our first term. Our first term is just 1. Right? F of 1 is 1. Our next term, f prime of 1, should be minus 1/2 of x minus 1. Then we need to figure out what the derivative, the second derivative of our function is at 1. So we'll figure out when n equals 2, we end up with what? Should be a positive 1. That should be a 1. And then this should be a 2 squared. So we should end up with 1/4. And when n equals 3, we should end up with a negative. And then we should have 2 factorial, so just 2 over 2 to the third. So that should be minus 1/4. Everybody agree with the values at n equals 2 and n equals 3? Okay, so we have 1 minus 1/2 times x minus 1. And then we should have plus 1/4 of x minus 1 squared. And then what needs to go in the denominator there? A 2 factorial. And then our last one should be minus 1/4. We should have an x minus 1 to the third. We should have a 3 factorial. And I don't believe they asked you to simplify those. They don't need to be simplified. If you happen to simplify them, that's fine, but these answers are fine. And then they ask for the general term. So our general term should be this negative 1 to the n minus 1 factorial over 2 to the n times x minus 1 to the n with an n factorial in the denominator. And so we'd want to simplify that one out a little bit. That should be negative 1 to the n minus 1 factorial over n factorial is just going to be, this is 2 to the n. Negative 1 to the n, we should have an n in the denominator. We should have a 2 to the n in the denominator. And we should have an x minus 1 to the n in the numerator. So there's your simplified down general term. Everybody good with that? You got 4 points for that one. 1 point for the first 2 terms, 1 point for the third term, 1 point for the fourth term, and 1 point for the general term. So 4 points there for part A. Any questions on part A? Everyone's good? All right. Part B says that this series has a radius of convergence of 2. And we want to find the interval of convergence. Well, we know that it is centered around 1. So if it has a radius of convergence of 2, and we're sitting there at x minus 1, well, then that should be the absolute value of x minus 1 is less than 2. That should give us negative 1 to 3. And then we need to check the endpoints on that to see if it converges at the endpoints. Everybody good with needing to do that? Yeah. So let's start with at x equals negative 1. If we put in x equals negative 1, what do we end up with here? We've got negative 1 to the n times negative 2 to the n. Right? So let's negative 1 to the n, negative 2 to the n. We had a 2 to the n in the denominator, and we had an n in the denominator. So if we simplify all of that out, we can take the negative 1 to the n times this negative 1 to the n. Negative 1 to the n times negative 1 to the n ought to be negative 1 to the 2n. And negative 1 to the 2n should just be what power you're always going to be raising to an even power, right? So if you take negative 1 and raise it to an even power, that's always just going to be 1. So we should just end up with 2 to the n over 2 to the n times n, which is just 1 over n. And what do we know about the sum from n equals 1 to infinity of 1 over n? This diverges, P-series test, or you could say it diverges, it's the harmonic series. Either one. And then at x equals 3, we'll have negative 1 to the n, 1 to the n, sorry, not 1 to the n, 2 to the n, over 2 to the n times n, which just gives us negative 1 to the n over n, which we know converges by the alternating series test. Or you could just say that this is the alternating harmonic series, which we know converges. So we would say that our interval of convergence is negative 1 to 3, inclusive on the third. I thought I said yes. Did I not say yes? I thought I said yes. Hmm,
That was for -3.
no, that shouldn't matter. Yeah, I mean, yeah. If it is the alternating, if I said yesterday that you can't just state that it's the alternating harmonic series, you can. Yeah, I mean, if it's the alternating harmonic series, you can say it converges. That's a known fact that we're good with. You can also say by the alternating series test. Either way.
If we were to say by the
I mean, it's better to. It doesn't specifically require that you do that, but I would recommend that you do it just to be thorough and make sure that the graders know that you know what you're talking about. Any other questions? Oh, point values for that one. Let's see. 1 point if you got -1 to 3, and that those were the endpoints, and 1 point for analyzing at the endpoints and getting non-inclusive at -1 and inclusive at 3. All right, part C says that this series can be used to represent f of 1.2. Use the first 3 non-zero terms of the alternating series to approximate 1.2. So all we're going to do is we're going to use these first 3 terms that we came up with earlier to approximate the value at 1.2. So we should have 1 was our first term, minus 1/2 of 0.2, minus 1/2 of 0.2, and then plus, this is going to be 1/8 of 0.2 squared. And I don't know, whatever that comes out to be. 181 200ths. I don't know. The answer key here that they've got their scoring guideline says 0.905. So, yeah. Well, I don't remember what you said. What did you say? 181 200ths. Okay. Yep, that's the same. So everybody good there with that? That was just 1 point for part C. Pretty easy, I think, for part C. As long as you had part A done correctly. Okay. Then part D, what was it asking? To show that this approximation is within 1/1000th of the true value. So this is an alternating series. So if it's an alternating series, we just take the next term, and that should be the bound on the error. So we'll say that the error is less than or equal to the absolute value of the next term. Our next term was 1/24 of 0.2 cubed. And that comes out to be, what does that come out to be? 2/10. What is it? Well, this is 2/10. That's 1/5. So really, that's a 1/125 times 24. 125 times 24. That should be 3,000. That's 1/3000. So the error is less than 1/3000. 1/3000 is less than 1/1000. And if the error is less than 1/3000, then therefore it must be less than 1/1000th as well. Yeah. Everybody good with that? 2 points there. 1 for setting it up in this alternating series error bound form, and 1 point for some analysis to show that that comes out to be 1/3000, which is less than 1/1000, which is the area of the error that we were looking for it to be less than. Just 1 point for the answer. Yep. Everybody good there with part D? Okay. Did I ask you guys to work on a couple of the area volume ones or no? I did, huh? Okay, I asked you to do the first 2. Does that sound right? All right, so those are the first 2 things we'll go over tomorrow, is the 2 area volume ones. Tonight, I would also like you to try to do the next two series ones in this packet. So this f of 0 is 0, f prime of 0 is 1, f of the n plus first derivative of 0 is negative n derivative of 0. This one. So page 3 of this one and page 4 of this one, the natural log of 1 plus x1 here. But they started you off with that series. So do those two series ones, and then we will go over the two area and volume ones that I asked you guys to do yesterday. We will also do those. And then if we have time, I'll have you guys work through another area and volume one together. Sound good, everyone? All right. I think that's a good place to be done today.